By now, you should know the basics of the Cartesian plane. Let's look at a straight line on the Cartesian plane. If we plot the points -1 and 1, 1 and 2, 3 and 3, 5 and 4 on a Cartesian plane, then join up the points, we get a straight line. This line represents an infinite number of points that have the same relationship between x and y, with the arrowheads at either end of the line showing that it extends infinitely in both directions. So a line on a coordinate plane represents much more than the points that are plotted. We can use the properties of lines to calculate gradient. But first, let's use an example to help us define what gradient is. Maya and Fidel want to improve their fitness levels, so they decide that they will hike up a hill once a week. An uphill walk is always difficult because it has an increasing slope. During an uphill walk, there is an increase in the horizontal as well as the vertical distance. In mathematics, we call the horizontal distance a run and the vertical a rise. The rise is what is responsible for making an uphill walk difficult. The bigger it is compared to the run, the steeper the slope. Walking downhill is easier. We still have a positive movement forward, the run, but the vertical movement, the rise, is from high to low and is actually negative. The informal definition of gradient is any change up or down in the level of a surface. Formally and mathematically, we define gradient as the rate at which the y value changes with respect to a change in the x value. Gradient compares a change in the y value to one in the x value, giving us a rate of change. In this graph, for example, the change from A to B takes only 2 units along the x-axis, which is fairly quick, whereas the change from A to C takes place over 6 units and is a slower rate of change. The gradient for AC is smaller than the gradient of AB. If we want to calculate the gradient between 2 points, we have to work out the difference in the change in y with respect to a change in x. To find a general formula for this, we start by labeling the points. Point A with the coordinates xa, ya, and point B with xb, yb. A right-angled triangle is used to calculate the gradient. Using this triangle, we will compare the length of the horizontal change, which is BC, to the length of the vertical change, which is AC. The vertex C has the coordinates xa, yb. The change in y values is equal to ya minus yb. The change in x values is equal to xa minus xb. To calculate the gradient between 2 points, we need to find the difference in the change in y with respect to the rate of change of x. In this triangle, we will compare the vertical change, which is the length of AC, to the horizontal change, which is the length of BC. The formula gives us the difference in the y values divided by the difference in the x values. Remember to keep the order of the coordinates the same to get the sign of the gradient right. We use the small letter m as a symbol of the gradient. For example, what is the gradient of the line segment AB? The endpoints are A at 6, 7 and B at 2, 3. The formula is the difference between the y values divided by the difference in the x values. The difference in the y values is 7 minus 3 equals 4. The difference in the x values is 6 minus 2 equals 4. So the gradient is equal to 4 divided by 4, which is 1. It is very important to use the coordinates of the points in the correct order to get the size of the gradient right. Negative gradients can also be calculated using the same formula. For example, if we took 2 endpoints in the following graph, A at 0, 2 and B at 3, 0, we can calculate the gradient of line AB. Remember, the formula is the difference between the y values divided by the difference in the x values. The difference in the y values is 0 minus 2, which is negative 2. And the difference in the x values is 3 minus 0, which is 3. So the gradient is equal to negative 2/3. What happens to a gradient when the line is horizontal? A horizontal line never slopes upwards or downwards, so the y coordinate is the same for every point on the graph. For example, Here are some points that lie on this horizontal line. 0, 3, 1, 3, 2, 3, 3, 3, negative 1, 3, negative 2, 3, and negative 3, 3. This means the difference between the y-coordinates of any pair of points on the line is equal to 0. Let's calculate the gradient between the points 2, 3, and 1, 3. When we divide 0 by any number, the answer is 0. So the gradient of any horizontal line is 0. If you climb a vertical cliff, you are climbing upwards only, not moving along. For a vertical line, all the points on the line have the same x-coordinate. For example, some points on this vertical line are 2, 0, 2, 1, 2, 2, 2, 3, 2, negative 1, 2, negative 2, and 2, negative 3, which means the difference between the x-coordinates of any pair of points on the line is equal to 0. If you tried to calculate the gradient between the points 2, 3, and 2, 0, you'd be trying to divide by a difference in x values which are all equal to 0. And when we divide by 0, the answer is undefined. The gradient of a vertical line is always undefined. Many different lines can have exactly the same gradient. For example, these two lines both have a gradient of a half and are therefore parallel to each other. When we calculate the gradients of two lines that are perpendicular to each other, they will have a certain relationship between their gradients. Have a look at this. Line 1 has a gradient of m1 equals 1/2. Line 2 is perpendicular to line 1, and the gradient m2 equals negative 2. What do we notice about the gradients m1 and m2? If we multiply the gradients of the two graphs, m1 times m2, the result is negative 1. So the product of their gradients is negative 1. This property is true for any two perpendicular lines. The general formula for a straight line is y equals mx plus c. The m and c are constant values for a unique straight line. We know how to find m, the gradient of a straight line graph. The value of c is the y-intercept. The y-intercept is the place where the straight line intersects the y-axis. A straight line going through the origin, the point 0, 0, has a y-intercept of 0. The y-intercept is the c value in the equation y equals mx plus c. The line with a gradient of negative 2 that goes through the origin has the formula y equals minus 2x. The value of c is 0. The line with a gradient of positive 2 that goes through the origin has the formula y equals 2x. The formula for any graph that passes through the origin will always have the equation y equals mx. If we shift both graphs up so that they intersect the y-axis at 1, what does the equation become then? The gradients remain the same because we have shifted the graphs without changing the slope. The equation for the graph with the gradient of minus 2 thus becomes, whilst the equation for the graph with the gradient of 2 becomes, that is, the value of c in both cases is 1. Let's see how we can find the values of m and c in the formula y equals mx plus c to describe a given straight line. The y-intercept on this graph is negative 3. Now we choose 2 points on the line to find the gradient. For example, let's choose negative 2, 0 and 0, negative 3. The gradient is negative 1.5. So the equation of the straight line is y equals negative 1.5 x minus 3. We can also find the equation of a straight line if we are given only the coordinates of 2 points on a line. This is because there is only one unique line that can be drawn through any 2 points. In this case, we don't know the y-intercept. However, we can work out the value of m in the usual way. Then we can use the formula y equals mx plus c to find the value of c. To find the value of c, we choose either of the points and substitute the x and the y value into the formula to solve the equation. Let's work through an example. Given coordinates a, minus 1, 2, and b, 3, 5 on a straight line, find the formula of the line. The first step is to calculate the gradient, m. The value of m is 3/4. Then substitute 1 point into the equation to find the intercept, or the value of c. The value of c is 2 3/4. So the equation of the line is y equals 3/4 x plus 2 3/4.